Today is day 2 of solving systems of linear equations algebraically using the substitution method. So again, this is the second method of solving systems of linear equations. First 2 days we were graphing. Today is the second day of using substitution. So for our do now, determine whether the ordered pair 4, -2 is a solution to the system. Remember, a system just means that we have more than one equation. Okay? So in order to do that, it needs to be a part. It needs to satisfy both of these equations. All right? So all you're going to do is you're going to literally take this. So remember, this is x and this is y. You're literally going to take these coordinates and you're going to substitute both of these in like you were checking. All right? So if you want to know if an ordered pair is a solution to the system, all you're going to do is you're going to substitute them in, which I did right here. Okay, so if you notice, on this side I have the first equation, and the other side I have the other equation. Now it needs to satisfy both. So if you notice, it does work on the first one, but it does not work in the second one. Alright? It's all or nothing. So please don't check one and say, oh, yep, I'm good. It's got to satisfy both of them. Alright? Remember, each linear equation has an infinite number of solutions. So most of the time there's only going to be one solution that will be part of the system. That will work for both. It's where they intersect, remember. So unless they are the same line, so two overlapping lines, they are most likely going to be one solution. All right, for question number 1, I have the steps for you so that you don't have to go back and forth between today's lesson and yesterday's lesson. So we'll start out very simple again. So remember, wherever I see a y, I am going to substitute in my 3x. Okay? So I'm going to take this and I'm going to plug it in for the other solution. And remember, the reason for this is I need to get rid of one of the variables. I can only solve one variable at a time. So I need to get rid of whichever variable is easiest to get rid of. So if one is already isolated, use that one, which is exactly what I did. Okay? So as you can see, I took 3x and I substituted in for y. So right over here, we have y. So I replaced it with 3x from the other equation. All right? Because now I just have everything in terms of x. Once you find that, then you substitute it into one of the other equations, and you have your answer. Okay, so my final solution is -8, -24. All right, so I wanted to do one of these. Now this looks very similar to y equals mx plus b, but remember, y equals mx plus b. These are both solved for x. Now these are the easiest types of questions because you can literally just plug it, you can set them equal to each other. Okay? This says that x is equal to 2y plus 7 and x is also equal to y minus 1. Well, we're trying to find when are x and y the same for both of these. So if x is equal to 2y plus 7 and x is also equal to y minus 1, that means that 2y plus 7 must be equal to y minus 1. So we're going to simply just set them equal to each other, solve for y, and then plug it back in. All right, these are the easiest types of equations, and if they are set equal to y equals, we know how to throw that into our calculator and see where the graph intersects, but these are x equals. Okay, they're a little bit different, but still, you set them equal to each other and then solve them just like you would any other equation. All right, so I solve for y, I get y equals -8, substitute that back in, and I get x equals -9. So my final solution is -9, -8. going a little faster today than I did yesterday. So feel free to raise your hand if you have any questions. I really just want you guys to have as many examples as possible. This really is just something that you have to practice to get better at. All right, so my question for you is, what variable should we isolate? Okay, what variable should we isolate? Now, I told you yesterday that you really can do these in multiple ways. So if you choose to do, let's say, your homework, or maybe you're pausing the video and you're doing these and then checking, which is great. That's a great way to practice. You might do it a different way than me. Now, I'm probably going to do it the way that takes less steps, but by all means, whatever makes sense for you. I will not be there when you're doing, well, if you do your homework in class, I'll be there, but if you're at home, I won't be there to give you your first step. If you're taking a quiz or a test, I'm not going to tell you what your first step is. So just because I do my first step one way, if your brain wants you to do it a different way, as long as you get the solution the same, that is fine. That's like the love-hate relationship we can have with algebra, is that there's really not usually one, like only one way we can do it. We have to use our problem-solving skills. So if you remember from yesterday, I told you when you are substituting, you're looking for that coefficient of 1. So I see this coefficient of 1 with this y, so my brain is telling me to solve this equation for y. So that's exactly what I did. So I solved this equation for y. All right, and then I substituted that back in. All right, so again, this is my new equation. So I'm going to take this, and I'm going to substitute it in for y in this equation. So that's what I did right here. Okay, be careful when you are distributing. Be careful with your positive and negatives. Make sure you combine like terms correctly, and then solve. So I got x is equal to 2. Remember, it does not matter which one you substitute it back in, as long as you're doing it to one of them. Because if you solved this correctly, then this will come out the same either way. Okay, so again, my solution is 2, 2. Remember always to put it in x comma y for your ordered pair. All right, getting a little more complex. So again, you are looking for that coefficient of 1. So I see this x over here, and I know that I'm going to get everything else away from it. All right? So I'm going to solve the first equation for x. So when I solve the first equation for x, okay, that happened, and I'll kind of put some step-by-steps for you. Okay, so this is the first step that I did. All right, I solved for x. And the next thing I did was I substituted it back in. All right, and finally, step 3, I found my other variable. Okay, so I saw that x is equal to y plus 3. Substituted it in for this equation, and then solved for y. Now be careful. Notice, y is equal to 2 and x is equal to 5. Just because I found y first, do not write this incorrectly, okay? X comma y does not matter how you solve it. This just so happened that I solved for y first. Make sure your final answer, and I noticed a couple of you were not putting your final solution. This work is great and it's necessary. You have to show your work in order to get full credit, but without this right here, you don't get full credit. All right? You didn't answer the question. It wants to know what is the solution to the system. Okay? Y equals 2 and x equals 5 is not the solution. The solution is 5, 2. Remember, our solution is a coordinate. Okay, that's why we start this chapter with graphing, so that you understand that we are solving systems of linear equations. A linear equation is a line. When we graph it, it is a line. So we're asking ourselves, when do these two lines intersect, if at all? All right, again, so now this one says, how many solutions does the following system have? So right there, that should be a red flag to you. Okay? So remember our options for this, just to refresh. Okay, when we have linear equations, we're either going to have one intersection or one solution, no solution if they are parallel, or infinitely many if they end up being the same line. All right, so if we were graphing these, that's easy to tell, right? We just look at the graph. But how do we do this if we are doing this algebraically? Well, I'm going to show you what it looks like. So again, I saw that x, right, that x has a coefficient of 1. So that's the one that I solved for first. All right, this one right here. So I got that x equals 10 minus 3y. So I took that and I substituted in for this x. Okay, so right here, make sure you distribute. Now here's the thing to look for. When solving, if you get a number is equal to itself, okay, they have to be equal. This means that they are the same line. They are the same line, which makes sense because let's have a look right here. All right, so this one, I'll leave this as it is. X plus 3y equals 10. Sorry, I keep using ketchup and mustard colors. All right, well, let's look at this one. All right, let's rearrange this first. I'll write 3x plus 9y equals 30. Well, if I were to divide this second equation by 3, what would happen? I'd get x plus 3y equals 10, which is the other equation. So right there, I presented you two separate looking equations, but when solved, they are exactly the same thing. So what we say, again, is infinitely many solutions. Infinitely many solutions. All right. I know this says now you try, but we're going to keep going strong. Okay, so number 6, this one's nice. You don't have to solve for anything. We are just going to take this one. It says y equals 3x minus 14. So I'm actually just going to take that and plug this into this equation right here. Okay, so I took this, substituted in for y, so it looks like this. So I isolated my x, and I got x equals 6. Substitute that back in, and we get 6, 4. Okay, and just so you have this one, I won't flip it back over. Okay, so this one was solved for x equals, and again, it works the same exact way. We just take this and plug it into the other equation for x. Solve for y, since we got rid of all our x's, and then substitute it back in right here. Okay. Here to here. And again, always make sure you write your coordinate x, comma, y. All right, two more. All right, so two choices for this one. Again, I would recommend this one right here. I would recommend solving that for y just because of all the positives. I don't want you to solve for negative y or negative x. I want you to solve for a positive 1 as a coefficient. So this one might look like, yeah, maybe I could do that one. And yes, you could. Again, there's multiple ways to solve all these equations. But I would say the easiest way would be like this. Okay? So we get y plus 3x equals 1. Just like I said, I would isolate this y right here, which they did right there. Okay, so y equals negative 3x plus 1. We substitute that into our other equation. Solve for x. And then make sure you substitute it back in. Guess I know. Again, I know this is very redundant, but the only way to get through this chapter is practice. All right? Because again, I'm not going to be there to give you your first step. You guys have to figure out what the first step is on your own. So please make sure you are really taking your time and doing your homework, and please come in if it is not making sense. All right, I did have to include one with fractions, so sorry. So number 9 is already solved for you, so that's a plus. We have x equals 1/2 y minus 5/2. Okay, so I'm just going to take this right here and substitute it in for the first equation. All right, don't get overwhelmed by these fractions, okay? 2 times 1/2. Basically tell yourself what's 1/2 of 2, okay? And then 2 times negative 5/2 is a negative 3. Okay, remember when we multiply fractions, you can put this 2 over 1, and you can solve it that way. Okay, that might be easier for you. All right, so I get y equals negative 9. And x equals negative 7. Okay, so the last thing that I wanted to talk about, and I'm going to refer back to one of your other examples. Let me just find it. Okay, so right here, this example, I told you that if you get something where 30 equals 30 or 0 equals 0 or one is equal to the other, that's called infinitely many solutions. Now sometimes what's going to happen is you are going to solve your equation and you'll get something like 0 is equal to 10. Okay, so all of your variables are going to cancel out and you're just going to be left with what looks like nothing. Okay, so we call this no solution. This is no solution. Okay. So I'm just going to show you a quick example. So I just wanted to show you an example of this. All right, and this is similar to your homework, but what I have right here, I want to solve this one with you guys. Okay? So for this question, I'm going to do it just like I would any other one. So I see that this has a coefficient of 1, so I'm going to solve for this one for y. And you can put this right at the bottom of your paper. I just wanted you to have an example of this. So this would be y equals x plus 3. So what I would do is I would take this guy and put it into this equation. So let's see what happens when I do that. So I get negative 3x plus 3 times x plus 3 equals 4. So pay attention to what happens. So I get negative 3x plus 3x plus 3 equals 4. Well, what happens here is what happens when I put these two things together? They cancel out. So I get 0 plus 3 is equal to 4. So 3 is equal to 4. All right? This cannot ever happen. So if you are solving a question algebraically and this happens, these are parallel lines. So this would be a no solution. All right? Neither of our substitution days had examples of that, so I just wanted to make sure that you guys had an example. All right, and that's the end of day 2 of substitution.